Hello everyone, welcome to the channel. In today's video, we're going to learn how to build our own on-chain scholarship and grant distribution smart contract and deploy it on the Conflux eSpace testnet. We'll be using Remix to write, deploy, and test the contract step by step. So without wasting any time, let's get started. First, I'll compile the smart contract in Remix. Once the compilation is successful, I'll connect my MetaMask wallet. As you can see, MetaMask is already connected, and this is the current balance of my wallet. Now, let's deploy the contract. The transaction is pending, so I'll confirm it in MetaMask. Once the transaction is confirmed, our smart contract is successfully deployed. Here you can see all the read and write functions generated by the contract. The deployer of this contract automatically becomes the admin or owner, who will manage the scholarships and applications. At the moment, there are no scholarships created, so let's create one. I'll create a new scholarship with the name Conflux Grant, add a description for testing purposes, and assign an amount of 4 CFX. After submitting the transaction and confirming it, the transaction is successful. You can now see that the contract balance has increased from 0 to 4 CFX. This means the scholarship fund has been added to the contract successfully. Now, let's check the scholarship count. As you can see, the count is now 1. If I fetch the scholarship with ID 0, we get all the details such as the scholarship name, description, and the allocated amount. Everything looks correct so far. Next, let's submit an application for this scholarship. I'll submit an application for scholarship ID 0 with a short application message. After confirming the transaction, the application is successfully submitted. If we fetch the applications for this scholarship, we can see the applicant's address and the approval status. Currently, the application is not approved. Now, as the contract owner, I'll approve the application for scholarship ID 0 and the applicant's address. Once approved, if we fetch the application details again, we can see that the application status has been updated to approved. Since the application is now approved, the applicant can claim the scholarship funds. From the applicant's wallet, I'll call the claim funds function. Once the transaction is confirmed, you'll notice that the funds are transferred to the applicant's address. The wallet balance increases accordingly, and at the same time, the contract balance decreases. This confirms that the fund distribution logic is working correctly. So as you can see, the complete flow works as expected. The admin creates a scholarship, applicants apply for it, the admin approves applications, and approved applicants can securely claim their funds on-chain. This ensures transparency and trust in the scholarship and grant distribution process. Now, let's briefly talk about the code. In this contract, we have a dedicated function to create scholarships, which can only be called by the administration. While creating a scholarship, the admin also funds it by sending CFX along with the transaction. Each scholarship is stored on-chain with details like title, description, total amount, and an active status, ensuring full transparency of the available grants. Applicants interact with the contract through the Submit Application function. This function allows any user to apply for an active scholarship by submitting a metadata URI, which can point to application details stored on IPFS or Arweave. The contract ensures that a user can apply only once per scholarship and that applications cannot be submitted once the scholarship is closed. For managing applications, the admin has the ability to approve or reject submitted applications. Only applications that are in the pending state can be approved or rejected, which prevents invalid state transitions and ensures clean application management. The most important part of the contract is the claim funds function. This function ensures that only the applicant whose application has been approved can claim the scholarship funds. It verifies that the application status is approved and that the scholarship still holds funds. Once these checks pass, the contract securely transfers the funds to the applicant's own address, updates the application status to claimed, and prevents the funds from being claimed again. These validations and state updates ensure that the system is secure, trustless, and resistant to misuse. That's it for this video. I hope you now have a clear idea of how an on-chain scholarship and grant distribution system works using smart contracts on the Conflux network. In the next tutorial, we'll build a front-end for this contract and interact with it using a user interface. Thank you so much for watching, and I'll see you in the next video.